for the product manager role, we deeply ask this design thing.
Yes, product manager role needs to be also technical. They will have understanding of system design concepts. Same curriculum, same kind of interview pattern will be there for product managers.
For that, yeah, I should also be more handy with a class diagram, sequence diagram.
As a product manager, yes, absolutely. Software engineers also have to be. So exactly the same requirement as product managers, no software. So software engineers and product managers, no difference in system design concepts. Coding part may differ, but yes, this part is exactly the same. No difference.
Okay.
Right? Coding part is the only difference. Right? And then assumptions when I'm taking, software developers can take assumptions which could be vague, right? Which may be off track. Say, for example, I say, yes, in the last session, I said, for Instagram, we will have 500 million users, active monthly users, right? Here, you have to be more careful because as a product manager, they should know exactly how many users will be there. So they should have a mechanism to understand and figure out what would be exact number of users, right? So their estimation should be more accurate in that case. Okay. Sure. So let me start with the topic. So this is about content. Let me start with some conceptual topic. We'll be covering design of Hotstar. System design of Hotstar is what we will be covering today. But yes, I will start with some theoretical concepts. Right, so we'll be covering today, the topic would be design of OTT platforms. Now, anyone knows what is OTT platforms? What is OTT stands for? Now, there are so many here. You have so
over
many.
the top.
Yes, absolutely. Perfect. Great. So this stands for over the top. So okay. But yes, before that, let me introduce you to one more important concept. This is a concept of CDN, Content Delivery Network. What it is, we will see. Anyone knows what is CDN? And where is it used? Right? CDN stands for Content Delivery Network. This I have already written. What it is. Everything in system design, mostly nowadays, are distributed system, right? So this is another kind of distributed system. That means, yes.
Like previously, we were having an application server, web server, where we're deploying our application. And nowadays, we are deploying our application on this CDN. Is my understand? No?
No. I'm coming to what exactly it is. But yes, I'm defining CDN.
Okay.
CDN is a distributed system, or you can say it is a network of servers, different kinds of servers. When you say distributed system, it could be network of different kinds of servers or different network of same kind of servers, right? These servers are located in strategic positions in multiple data centers So I would say, yeah, strategic geographic location in multiple data centers. Right. So what does it mean? Right. Say, for example, I am creating a website. This website has a market in India, US. So definitely my strategic geographies will be US, India, right? And if India, I have, say, some cities where I want to target, I may also have that, right? So these are my strategic location. Maybe in US, there could be some strategic location. So we can say San Francisco, right? Right. So should you spell like this? Yeah. Great. So San Francisco or say Washington, right? So and India also has some strategic location, say right. So there could be some cities, basically important cities where you will have the servers. Right. So I'm just putting geographic location. This is C. So basically here these locations are where most of your users will be. So best thing is provide the content to them from the nearest location, right? So data centers, these data centers which you will be building, they will be located near to your users, right? So let me get some users also here. So now I got the users. So you have users here, right? In various cities. Assume you have a website. So the website is, let's say, this is your website. Let me get a website also quickly. Yeah, but right. So this is my site. Maybe it is delivering different kinds of content in website. What all content is there? Website will have images. Website can have videos. Website can have style sheets, or this is CSS I'm talking about, right? This is static content. Definitely website can have text, right? This is also something which can be served from CDN. Website will also have JavaScript. So yeah, video, I would say audio also. These are different kinds of static content. Correct. Now, what else? Any other example of static content? Right. So these are various kinds of static content. This has to be served via website. Now it's very important for users to get very fast performance, right? Otherwise they will not get good user experience. To get them fast performance. So what CDN does is you have a content creator, right? So probably there is a content creator. So content creator is maybe a person actually who is creating the content, or it could be an organization maybe which is creating programs or a lot of other stuff, the content. Now content creator, yeah, this is content creator. So this is, I'm just replacing the text here, content creator. Yeah. So this guy is uploading, there will be a content server. Here, this is the content server. So, correct. So here, they are uploading the content to content server. And content creator could be in any location in the world, but may not be near the users. Right? So for example, this is a content creator. It could be any person, maybe singer or a studio, right? Say, and then they create videos and upload into the content. Now, to serve the content to the users all across the world, what generally people do is they copy. Basically, CDNs are nothing but servers which will take care of fetching the content from content server. And then they will be replicating the content to all the other edge servers. This is called edge servers. So right. So whenever there is a new content created, assume this is the new content which is created. This will be automatically replicated by all the edge server. So basically, this is the CDN service. So, right, let me reuse this. So this is the CDN service. This person has purchased this CDN service. What does this service does is it is giving access to content created from the servers which are located near to the user. So when these people, these users, they are viewing, they may be in US, so they will be getting the content from the US server. When these guys are viewing, these guys are in India, they'll be reading it from server which is nearer to their location, right? So basically there is the load balancing, right? There is dynamic routing which is happening from the IP address of the users. It is determined what is the location and what is the server which is nearest to the user's location, and the content is served from there, and these content is cached. So that's how you get very fast performance. So in Netflix, in Hotstar, in any of the applications, even in YouTube, you see the popular videos are cached from CDN and they will be served very fast without any buffering to users. So this is about CDN. There are many benefits of CDN. So what is the benefit of CDN is faster load times, scalability, because see, anyone, why scalability? So the content creator's server may be some
Nearest to user.
Yes, less powerful server. He need not have to have very powerful server. Less powerful server. So here content server is a less powerful server, but actually the content is not getting served from this. Content is getting served from the copies in the CDN. And these are anyway powerful server because these are maintained by some companies. So the most popular company which is providing CDNs are, so one company is Akamai, right? Have you heard of this company's name? This is a very popular company. They are,
yes,
they are the #1 leaders in CDN, right? So this is what they do. And they have powerful servers. Content is served from these powerful servers and they are load balanced already. So you can have many users who can millions. So CDNs can serve content to hundreds of millions of users. So this is the scalability. So without having any powerful server, you get that by default. You have to subscribe to the CDN service. CDN service will be very expensive service. But yes, if you can serve this content to millions of users. You don't have to worry about maintaining powerful servers by yourself. So other advantages, high availability, right? So again, you don't have to take care of availability. Even if your server is getting crashed, here this content server is getting crashed, these servers are always up and they are highly available. So you get high availability also from CDN. Also in CDN, even if these servers fail, right? Say for example, if these servers also fail, this company, the hoster, they take care of backup, redundancy, reliability, etc. So they will use multiple clusters of servers. They'll have a lot of backup servers so that in case some server crashes, you never see the impact of the crash in the performance of your content delivery. Right? This is there. Definitely load balancing is there. Right? And then the last advantage is it also saves less bandwidth. So network bandwidth reduction. And bandwidth is anyway, money means money. So this also saves cost, right? Basically, when you serve, if you serve directly GBs of content to the users, then you need to have that high bandwidth so that you can provide this service to end users, but you don't need now high bandwidth. High bandwidth is required by the CDN servers, and they will be dealing with the bandwidth. You may just have to take care of this connectivity, which is a small connectivity, right? But yes, basically the high bandwidth stuff will happen here. Right? So let me draw a double circle here just to indicate this is high bandwidth. Right? So this is high bandwidth. This is high bandwidth because many users will be getting the content here. So these servers should be able to deal with a lot of network traffic here, these CDN servers, but you don't have to because you are just connecting to one server, which is checking, is there any update on this content? If any update is there, then this update is provided to the CDN network and all edge servers are updated with the latest content. So this is what the functionality of CDN is. See, these are the content which you can cache. Basically, this is what you can cache, only static content. So these all should be static content. Right. Now, let's move to a topic which is about designing Hotstar. So yes, as we know, OTT platforms over the top, there are plenty of examples of these OTT platforms. For example, Hotstar, Amazon Prime, SonyLiv, JioCinema, right? These are different examples of OTT platforms. Today, we will be covering how the live streaming happens, right? So these platforms provide live streaming. Live streaming is, you have, say, IPL or football or soccer World Cup, right? So there will be again hundreds of millions of users which will be watching it, right? And all of them will be watching at the same time the same content, and they will expect good performance. They would expect a smooth performance over the network. Maybe they may be on the mobile network or they may be on Wi-Fi network. Not many people will be on Wi-Fi network. Nowadays, many people will be on the move while in train or in bus or in cars, they will be watching it over unreliable network. But your application should ensure whatever is the device, maybe they will be using some cheap devices. Not everyone will be using high resolution iPhones, which are stable devices with a lot of processing power, but they may be using some mediocre devices or cheap devices with less data rate. Still, they would be expecting good experience in watching these sporting events. So how this is done and how is it taken that user gets best in class experience? So that is what we will be discussing today. I think clear, the problem is clear. So that's the functional requirement. Here the functional requirement we will be dealing with. Live streaming of sporting events, or it could be music concerts also. That does not matter, but yes, you would have the live meeting, live video event going, and the live means actually it's not live. When we say live, there can be some delay. How much is the delay in live? Any idea? Right? So a delay is less than a minute, right? So maybe
Yeah, 30 seconds or 50
30
seconds.
seconds is something nowadays. Now, earlier it used to be 1 or 2 minutes. Now,
Yeah, like
because,
I noticed 1 or 2 minutes lag.
yes, 1 or 2 minutes lag used to be there, but nowadays in many platforms, they have reduced it. Now it is 30 seconds, right? Maybe 30 seconds, 40 seconds. This may
We,
vary,
Mhm.
but yes, nowadays it's getting lesser and lesser. Lesser is better, right? So I will give you the requirement that please design for, say, 30 seconds lag. Correct? So we will be designing that latency will be 30 seconds. Right? So latency. What does it mean? If a user opens an app, let's say mobile app, this is the mobile, right? So let's say this is the user. He clicks on the match link, right? So he will assume this is the 2 IPL match which is happening. He clicks the first one. The video should get started immediately. No lag, 30-40 seconds he'll not be waiting. As soon as he clicks, immediately the video should start playing instantly in less than, say, 0.5 seconds. So response time is 0.5 seconds, right? So within half a second, he should see the match video getting streamed. But yes, the stadium, whatever is it happening in the stadium, this is a delay. There will be a delay of 30-40 seconds. So clear this difference between latency and response time, right? So just note there is an important difference between latency and the response time. Right? This is one requirement. This is the most important requirements. So functional as well as non-functional requirement. And definitely other stuff I have already spoken about, that you need 100 millions of users to watch at the same time. Right? How can we do this? Let's do the system design. Back of the envelope calculation, etc. We will again do here. But basically your there could be other requirements also in Hotstar. If I say I have to list all the functional requirements, Hotstar or Netflix or any other platform, they will also have recorded content, right? So they should be able to have videos there. When you click on the video, it's not live. So there could be a lot of optimization which could be done in the backend for delivering the videos or TV shows, right? So here no challenge, but maximum challenge is in live content, right? Definitely user can search for shows, search for matches. There could be some recommendations also can be provided by the platform, right? This is done using AI. Various machine learning algorithm are there, which will track the user behavior, and based on it, it will suggest the content. And you should be able to review, right? Sometimes people can rate and review the content also. They can put their comments, and this is other features which is offered. So these are various functional requirements, right, for Hotstar. Right, and best definitely one important functional requirements which we have to take care is playback management. What does it mean? Anyone?
Forward, reverse, pause.
Yes, absolutely, right. So we should be able to play, we should be able to pause and resume our content, both for, we should be able to rewind, we should be able to forward, right? Forward or fast forward, right? Even for the live content, right? So yeah, you can't do forward for live content, but yes, you can do other stuff, right? We can't do just what will be the final, right? If it's a live match, fast forward, but yes, you can pause, you can rewind, you can watch something again and again in the live content also. But yes, pause also you can do, and resume also you can do. And but yes, only thing which you cannot do in the live is fast forward. So just take care of this. Hope you understand. Another important thing, which is authentication and authorization, right? You should have paid the subscription, and then only you should be able to watch it. So user verification should also be there. There should be username, password creation possibility. You can also create your profile also. So you can have a user profile where you can upload about your interest. You can do some kind of commenting, and you can put some personal comments. You should have a user profile. That is also possible in Hotstar platforms, right? And when you have the profile, definitely you will do subscriptions. You will get different options of subscriptions, and accordingly you can make the payment. So you should should also be able to store credit card information. It should be handled securely, right? And in the profile, you may have your name, email, phone, etc., and credit card number also. So this is all about functional requirements, right? So when I spoke about non-functional requirements, we said about latency, response time, scalability, right? So yeah, let me move this here. So we get rid of all this. But yes, when I said about non-functional requirement, we said about this scalability as well. We talked about performance. Performance is all about response time, right? So this one, a response time. This is another thing, important thing, which we should consider. So again, basically, there are two kinds of things. One is 100 millions of users could be the subscribers. But at the same time, people would be watching also, right? See, any platform will have subscribers which will be in crores. Maybe 10 crore subscriber, 5 crore subscriber, that is possible. But concurrent user for a match, say maybe match is between IPL, there is an IPL match between Hyderabad and Bangalore. Mostly all subscribers may not be watching. People in Delhi, they may not be interested in it. But yes, many users, maybe 20 million users are concurrent user watching that match. So understand this difference between total subscribers and here this is your concurrent users, right? So this I have already mentioned here. So we need to define the scalability requirement in terms of both. Next thing is any other requirement. Is everything covered? Now, as an architect, you should be able to think and tell me, yeah, this is all good enough. If we have, this will be a decent platform, or do I need to take care of some other important requirement which I have missed out? Because as an architect, it is very important that you can figure out whether the requirements are correct or not, or they are complete or not. I've purposely left out one important non-functional requirement. Yes, here we have covered. Figuring out this is not a big deal. This even anyone can tell, right? My grandmother can also give the functional requirements correctly. But non-functional requirements only experienced software engineers will be able to provide. So this is more important. Now tell me, what is the other very important functional requirement which I missed? I've covered performance, I've covered scalability, I've covered latency, I've covered privacy, user profile when I talked about. I covered security, payment and all, right? So yeah, I'll just mention this because better to have explicitly mentioned. Privacy means your address, email ID, etc. should not be shared with unauthorized people. so that they start calling you for personal loan or for some other fraud, etc. So your email ID and etc. all these information should only be used for professional purpose by the Hotstar platform, right? Maybe sending you email about important matches, etc. or reminder for your payment of subscriptions, etc. or any offer related details, but not for unwanted calls. Also, this is security. Security, you guys understand. That means your credit card should not get misused. Otherwise, you will have financial implications because of you will lose money basically, and then you will sue the Hotstar platform and they have to compensate for your losses, or yes, they will get a bad image. They will lose users' trust. So this is about security, privacy. Tell me what is important. Requirement which is left out. Need hints? Should this matter or not? What kind of availability should we have? Should have high availability, low availability? Yes. So availability is what I missed out. Perfect. I see some responses also. Availability is important. Yes, also device independence, that is also fine. Yeah, it should be able to be viewed in different devices. That's also good, but yes, availability is important, right? Now, I last time covered that the availability we measure generally 99.9. That means 3.65 days. No, this is 99 availability. Site will be down if availability is 99%. But yes, what do you need here? Right, so maybe 4 nines, 5 nines. Yeah, you would need actually around 5 nines of availability. 4 nines are also fine also, because right, that means 0.365 days. It's down per year, right? So 4 nines or 5 nines availability is something which we'll be preferring here. Nice. So 99% is 3.65 days down, and 99 I put 2 zeros. 999, one more zero I have to add, right? So this is my availability, right? So now we'll ensure how to do this, but let's do back of the envelope calculation. How much storage do we need for, say, Hotstar? So Hotstar have TV shows, movies, recorded content, right? Definitely for live, you don't need the storage, but yes, you have recorded content as well. So for recorded content, so let's do the storage calculation. Let's not talk about live content at the moment. Let's say recorded content. How many movies do you think we have in Hotstar? Do we have all the movies?
Not all the movies.
right? So maybe few regional movies, few English, Hindi, different language movies. So how about 10,000 movie? Sounds decent,
Yes.
right?
Yeah.
10 movies would be there. Some movies could be short, some movies could be of longer length, right? Also, let's say we have some TV shows also here. So everything included, because see, they take away the movies also. And they have only few movies. They don't keep all the movies and they remove the movies also, right? Do you know what is the reason? Why do they remove the movies? Why not keep everything? Like YouTube never removes any video. You'll always have that video until unless user removes, deletes it because of for some reason. But yes, if you upload, do no action, it will be there forever. They never delete the videos. But Hotstar does that. Why? They want to save storage.
Some kind of partnership issues, with that.
There could be some licensing issues. They might have taken contract. But is there any technical issues also? But yeah, these guys are also rich guys. They can also extend the contract. Right? I can take some movies are there, which is very old. But storage, storage is cheap these days. What is expensive? I showed yesterday that, okay, 1 terabyte information, you can buy a hard disk for 1 terabyte for around 12,000 rupees these days. Yes. So storage could not be issue because in 1 terabyte, you can get many movies, maybe 1,000 movies, because 1 GB is what you will need. Even to store 4K, maybe you need 10 GB. So you 100 movies you can store in 11,000 rupees. And these companies are very rich. You see, in YouTube also, you have a lot of unwatched content, but they don't delete it. Yes. So the reason is what is expensive is the CDN. YouTube do not have to ensure that everyone gets a premium experience. Right? For some videos, you may get some delay, blurry, noise quality problem, etc. Right? But in Hotstar, they have to ensure the video, sound quality, everything is perfect, is professional quality. A smooth video, high resolution video is available for all the content, and it should be fast served through CDN. So they have a limited space in the CDN. They want to save that, right? And also they want to show good content also. User experience could another be issue, because if some bad movies are there, you may not like that. And there could be more clutter. So because of reasons of maybe some movies are not that popular, so they don't keep it. And over time, the movies and content lose the popularity. So they remove it. They may remove it due to contract issues, but very important technical issues. CDN is the expensive thing. For every 1 GB of information, they may be paying sometimes in millions of dollars if that content has to be kept in multiple edge servers for different geographies in CDN. So CDN are very expensive. So having less movies will cost them less money, considerable money. Because yes, if you are a billionaire, you don't care about 10,000, 12,000 rupees. But yes, in CDN, millions of rupees you will care about. Millions of dollars you will care about. Okay, so for 10,000 movies, let's assume every movie is 1 hour, average size. right? Simplifying the calculations. And for each of the movie, what kind of resolution we will store? You will store HD, you will store 4K, or you will store SD, or even lesser, low resolution, which could be, say, 480p, right? Which resolution should we keep for all the movies? Or do we need to keep all the resolutions? Right? Because definitely, the same movie you cannot watch if it's not stored in 4K, in 4K TV. If you will not be getting good resolution. So you have these many resolutions. You have to store all, but why? Why to store this less resolution? Right? 4K is there. So maybe you can give the 4K content, and if device is not capable, then no, you can watch 4K movies in HD TVs also, right? On mobile also, even if it is a low-end device, you can choose the 4K. Maybe you will not see the clarity, but the device will support. Right? It's not worth watching. You will not get that sound and video quality. But yes, you will still be watching 4K. If 4K video is there, but HD is your device, you'll watch it like HD. So why do we store low resolution? 4K movies may be taking more time to load, right? Because they will be heavy files. Maybe 10 GB will be the size. So yes, if you watch on HD device, you will get slow performance. Also, you will get a lot of bill from Airtel or from Jio or whatever, because the bandwidth consumption will be high, right? And the entire day, either you have to keep recharging it, or you have to live with that poor network connectivity. You have to keep searching for hotspots throughout the day, right? So yes, they put all these resolutions so that if the device is low end or if the network is slow, they can serve the content faster, right? So, and they save bandwidth and they save network cost, right? But yes, how can servers detect the device? See, this is my server. This is Hotstar server. Let's talk about Hotstar server, right? So here, let's say Arun is watching with iPhone and he is having good connectivity also. At the same time, say Ramesh is also there. He is watching this content, maybe, yeah. He has iPhone 14 Pro Max. And yes, maybe Arun has, yes, he got Redmi, right? Maybe, yes, he just lost his iPhone and now he has switched to Redmi, which is just 480p pixel. Yes, temporarily he maybe has given his iPhone for repair and now he has got some device which is 480p backup device. But here, yes, what Ramesh is watching is with 4K device. He's also watching the same IPL match, Hyderabad versus Bangalore. How does the server knows that this guy has the iPhone, this guy has a low resolution device. How can this detection happen? So that he gets the 4K content and this guy gets the 480p content, because it doesn't make sense to transfer this 4K to this device because this device is not capable of. Right? Let me remove this. Yeah. One. So this is how does it happens? Can anyone tell me?
As you said previously, based on the processing speed of the device.
But yes, how does the server knows what is the processing speed of the device? Okay. Which system properties? Correct?
Client mobile.
See, this guy, they may send HTTP request to get this IPL match in the HTTP server header. Right? In the HTTP header, you get the
Device type.
details of the device, right? So
Yes.
yeah. Say for example, developer tools, if I open and in this, if I make a request, right? So I don't have any request going, but yes, in network request, let me show you some other example where I can demonstrate that. You have the device. So there are various techniques for doing detection of the device. So, and device detection is used here. This you should be aware of. Right. So let me just demonstrate to you. Okay, let me show you here. So let's say here is my system, right? So here, see, I have made a request. So you have here the payload HTTP request. This is how, right? These are the information which is being shared. But yes, let's go to Hotstar site. Let me pick any. Yeah, let me now. I'm still in Google now. Now I'm in the Hotstar. You can also do this at your end also. So you see here, there are a lot of requests which is going on, right? So let's say some request we take, right? So if I go to some request here, you see here, there will be headers and other stuff which will come. So let me try going into the details. Okay, it took me to the next page, but yes. So here in the headers, you may get some information about what is the device type, right? So agent, you see here, this user agent, it shows information, right? So that is one way. What is the other way? But yeah, this is for browser, right? But this guy is using mobile app. Right. Even in mobile app, it is even simpler, right? Because when you install in the Play Store, that information, you know that, okay, what kind of device is there, right? That's another technique. So maybe for iPhone, you give a different app. So you know that this is Apple iPhone because it is being the agent you can put Apple iPhone app, right? In this Android, and maybe for lower devices, you have a different APK. Yeah. So that's one technique. So there is a lot of techniques which is there. Other technique is about fingerprinting, device fingerprinting. They may use multiple properties, right? Agent details, and they can kind of do the detection. Now, next thing is, let's say now his mobile got repaired. And now he has logged in. This is Ramesh, I believe. Yes, he has got the now iPhone back repaired. He's watching this, but he still is on slow network, right? This guy, he has is still the 3G network, right? But let's say he has iPhone device, but this guy is in 5G network. How can this be detected that this guy has a slow network, this guy has the fast network, right? Can the network detection can also happen? Because if I send 4K content to this user, right? Let's say this is user 1. Since the bandwidth is 3G, does not make sense. Maybe I should send him HD content, right? Because he is on 3G network, right? See here. So any idea about this, how I can do that from the server? It's also simple, right? See, when I type speed test in Google, there is a speed test app, right? You have other apps also, Okta and all. But yes, when you do the speed test, see this, my speed is getting checked. How is it this app working? How it is trying to detect? It is also detecting download and upload speeds. How does it happen? Right, your internet connection is fast and gives me details and I can check this. What actually happens? We can see what is happening. Let's say test. See, it's not happening at the HTTP level, it's happening at the lower level, right? But yes, see something ping and all is there. But yes, see, there are a lot of requests which is being made. So what do you think is happening here? You have see these pings. See if I can see the graph of the network graph. Yes. So let's say continuously kept sending the requests. A lot of requests were sent, but yes, efficiently sent. In one, they have sent multiple packets, but it's a long request which has been sent. Right? So the way you can detect is you can see how much data is there in the, how much data got downloaded in the app, right? So download and upload speed could be determined. Upload is definitely, you will upload the data and see whether 1 KB file is now with server. So when you click upload, it starts the counter. And if say 1 GB file took 1 minute to upload, because server gets the file, so definitely upload speed can be detected, right? Because if server gets the file in 1 minute, it knows that yes, 1 GB took 1 minute, so that this is the speed. But download, right? Once the entire file is downloaded, the client can send, yes, I have received the file. So it can send a notification. See here, there is a mobile app. You have everything in control. So you can see how much data is there in the client, and client can notify to server that, yes, I have got this much of data. So you can say that if 100 MB data is there as a buffer to the client, then I am good. Please upgrade the resolution for the next package. If it is not, you can say that no, the network is slow. I don't have 100 MB of data. I have only received 50 MB of data. So for next packets, please reduce the resolution or quality. So see, dynamically, you have to vary the quality of the package because network condition can vary. Maybe user is traveling. He started from the office was very good connectivity. Then he went into the lift, very bad signal, maybe disconnectivity, but still there was some buffer space. So although the lift was not having any network, but in few seconds, person came out of the lift, but he's still watching the match. And then he moves out and sits in a cab. There is a different resolution, different speed available. So you can dynamically vary the video quality. Clear? So network detection, is it clear to you all? How is that? So these two techniques are definitely important in system design. You have to talk about it. So yes, you need to store all resolutions, and how you will utilize that, this will depend. But let's assume for 1 hour video, 4K is 1 GB. HD video is 500 MB. SD is maybe 100 MB. This is say 50 MB. You can just do some calculation, maybe 50 or say 20 MB. Yeah. So for one video, how much storage is required? 620. 1620 GB. And for 10,000 videos, how much? So this is per video. For 10,000 videos, you require maybe gigabytes, right? Or terabytes, right? This can be done in this terabytes. Again, you don't store videos in the database, so no need to decide about the database, but yes, this will give you idea of how big is the scale. And maybe you will have to copy it 3 times, because what if maybe you have purchased a movie say some movie, very costly, millions of dollars you spend in rights, and the hard disk where you stored that movie crashed. You lost millions of dollars because movies now cannot be streamed because hard disk is crashed. To avoid this, you will back up, right? You will back up at least 3 places, right? So you can do multiply by 3, still it will come as 48.6 terabytes, or let's say 50 terabytes. It's still manageable after backup. Within 50 terabytes, you can host the entire Hotstar. Right? But do we need a database for Hotstar? And if we need, then we have to design the schema as a system design exercise. Yes, you need. You need the database for Hotstar. But yes, what you will store in the database? Can you search movies in Hotstar?
Yes.
Right. So yeah, you will store the metadata about the movies. Absolutely right. You will also you store the user details. So yes, you need S3 for storing videos. S3 is a file system, distributed file system, cloud storage. Amazon has S3, but yes, in Azure, in Google's GCP, you may have similar cloud storage or distributed storage, which you can use. But yes, definitely you need a database to design. So for movies, for user details, right? I believe movies and users you can design very simple, right? So user ID, name, email, address, right? Credit card. Now my question is, subscription to user. Yeah, you may have a subscription table also, because see, subscriptions is also important. Subscription could be type, start date, end date, right? All this information is there. So a user can have how many subscriptions?
User can have one subscription, but
Right.
4 devices,
Yes, yes. Yeah. Okay. Nice, nice. Yeah. So our database for device should also be required, so that you can check whether user is accessing it from 4 device or not. But good point. Yes. Right. So all the devices which are watching, you get to know. And you know, for per subscription, is the same subscription be valid, or you need a new subscription so that you can block. So a user may have many devices. User will have one subscription at a time, valid subscription at a time. User will make multiple payments, one to many, right? A payment cannot be made by multiple users. Only one user will make payment, but one user can make multiple payments, and a user can have multiple devices. So all these one to many relationship will be there mostly, no many to many relationship. Movies will have many actors, right? So an actor can work in many movies. So if you are creating a separate database for actors, maybe you can think of creating a separate, because for actors, you may have to share the biodata. You may have to share the photo and some details about the actor also. So you can have, this is a many-to-many relationship. Right? Yeah. So all these you can implement, not a big deal thing. So database size also you can calculate, because see, there is only 10,000 movies. You may store thumbnails. You may store other details also, like actor. You may have a description of the movie, genre of the movie, director, music director, many fields, release date, etc. But still, you may say that per movie you will have maybe 1K of, or maybe 5K, or let's say 10K data per movie, which is the metadata, right? It is all metadata. 10K into 10,000. That means 10K into 10K. How much storage you need? 10K into 10K is how much? Very small number. Right? Is in GBs. Tell me in GBs, how much GBs, how many GBs that, right? Hmm, 10K into 10K, how much it is? 10K means this into this, because bytes, right? So this means how many 0? 448. Right? So this is 8. I think one more I got. Right? So this is KB. This is MB. This is GB. So you need 0.1 GB data. Yeah. Data volume, not a big deal. Read and write is a big deal. How many users will be watching concurrently? Millions of users could be watching concurrently. That means you may have millions of requests per second. Right? Say, I said 50 million concurrent user. So you may be, now a new movie got released in the prime time, right? 8 p.m. it got released. Everyone will watch in 8 p.m. Right? Mostly 50 million people can watch. So write and read is more. Write is very less. Maybe once a day one movie is getting released. Write is slow. But yeah, if you are writing the user activity, right? See, you will also track whether the user has paused, what all things they have paused. So they store entire telemetry. So that is a lot of data. But yes, this is a read-heavy database. Will not be writing that often. So here, what I would suggest, you may use, with what you will use, SQL or NoSQL. What I would suggest is you may consider using Elasticsearch. This is a database. Is a NoSQL database. Very simple, easy to use database. You can read about it. basically what it provides text search, right? So it has text search capability because that may be required for searching a movie, right? So you may want to search with any actor, director, maybe some plot of the movie you can search. Show me war movies, or fuzzy search may also be possible in this. Anyone knows what is fuzzy search? I would introduce one term. Fuzzy search. Fuzzy search is search if you misspell. Right? You don't need to match exactly the, say for example, I am searching for right something, some difficult name, right? So maybe I'm searching movies with this actor. Right. So, but yeah, I might have misspelled it, right? Something like this, or some misspelling I do. Still, I will get the result. This is not possible with SQL. Correct? In relational database, it's not possible. In that case, you would need to write your own service for searching. But in Elasticsearch, you get it out of the box. Fuzzy search comes out of the box. Right? Say, I have maybe one description is something like this. Right? That, okay, this particular film has received many, say this is some description. The film has won, let's say, has won numerous Academy Awards, right? Say, for example, this is the description. Now you search with Academy Awards. This is possible, but your search will be very slow in relational database because it's not indexed per word, right? We can index the column, but we cannot index individual words within the tables. So that is another disadvantage of relational database. So I will advise use NoSQL databases. MongoDB could be used, but very similar database, which is also JSON database, but it provides more search capabilities, Elasticsearch, right? So you can use this. This is more suitable than MongoDB. MongoDB can also do good text search, but yes, Elasticsearch is much better in searching. Now, next thing is, yeah, this is how we'll design the static content playback part, but let's talk about live content. So let's do the designing about live content. In live content, let me draw. I'm trying to draw mic. Yeah, because yeah, this is the mic. I'm also trying to draw a camera. Assume this is the camera. Let me draw like this. It's close. Yes. Basically, cricket match is happening. First thing, the video will be there. Where? In mic and camera. This will be recorded in mic and camera. Right? Let me write it because it's not that. This mic. Right? And this is the stadium. Yeah, cricket stadium is also there. Let's say this is the stadium. Yeah. And recording is happening from mic and camera. This is the stadium. Mic and camera are in the stadium. Now you are a user watching millions of kilometers, not millions, thousands of kilometers. We are not in Mars, but yeah, we are thousands of kilometers away. So this is the user. He's watching this in his mobile device. Let's say, yeah, this device could be any device, iPhone or Redmi or anything, Oppo or something. So you know the device, but how this image in less than 30 seconds will come to this device is the challenge. You have 30 seconds. You have to travel maybe 10,000 kilometers. Match is getting played in Australia and you are watching from India, right? 10,000 kilometers away. How will this happen? Now you said, okay, you will store all these formats, right? 4K, HD, can you store all these formats? But is there any video here? So let's see how it happens. Interesting. We'll discuss this in next 15 minutes. I'll give the design. This is your server. There will be a server. Maybe Hotstar is doing the relay. So they will set up a server here. You may have a high-speed connection here. You have to ensure, broadcaster will ensure high-speed connection. Right? In cricket matches, possible because stadiums will have good internet connectivity. You can ensure. But sometimes, some events are happening in remote area. Like, for example, there is a flood in some area and there is a live telecast of that flood rescue operation. Right? Maybe that is a remote location or a war zone. There some live telecast is happening. In that situation also, they establish high-speed connection, but they have a lot of money. So broadcasters can get the satellite connection, internet connection. So they establish high-speed connection and they have this server room. Server where they will store this video content which is coming directly from the camera and mic. Right? So you will get the file, which is the video file. This is a big file. You cannot wait because if you are waiting for the entire file to come, the match will be over. Yeah, live will not go. You have to start chunking it. Start slicing this content. How much slicing you will do? Tell me. Should we do every minute? Slicing of every minute? Or should we do 30 seconds? Or even lesser than 30 seconds? Because 30 seconds is our chunking. Right? If I keep 1 minute as a slicing time, and then what I get from this 1 minute video content, maybe I will do the conversion to various format. 4K, HD, maybe 480p, etc. Right? If I do. So 1 minute, every 1 minute, I will get all these files. And this I can feed to CDN. So I also take so my content server will send these to CDN. And CDN will copy it to various edge servers. Let's say this circle, or let me change this to rectangles, right? And these are my servers in different strategic location. Maybe if the audience is in India, there will be a server in India. If audience is in England and US, edge servers there. But yes, this content is replicated and the user views from a server which is near to him. Any problem in this? What do you think is the latency?
So when we are segregating the videos, long videos in small chunks.
Of 1 minute each, yes.
So while doing that, we'll maintain this quality also 4K. Well, like for 4K, we store different videos.
Yeah, assume this conversion of various format. This can happen in say 5 seconds. For right?
Okay.
So you have the latency which is 1 minute 5 seconds. Correct, because you have to wait for the minute to happen. Then only you will chunk that file. Then you will convert it into various formats in 5 more seconds. Then you will relay it. Maybe replication also takes maybe 2 seconds in CDN. And then finally, this user gets it. And maybe here there is less delay, but 1 second delay is there. Right? So if you see here, there is a latency of 1 minute and say 7 or 8 seconds, right? Which is not meeting a requirement. Our requirement was 30 seconds. So how do we solve this?
We'll put more content server.
Pardon?
We'll put more content server.
No, but chunk size is 1 minute. So 1 minute you have to wait for that content to generate it. Then only you chunk it. So with 1 minute, you cannot do that, right? You need maybe, let's do it 10 seconds, right? Chunking should be done 10 seconds, around 10 seconds, less than 30 seconds. It may also happen, you transfer the file, right? This file got transfers, but while on the move, the packet is lost. That can happen. So, but yes, do you see any jerky video or something, cutting video? You get a smooth video. So what actually happens? There's a concept of checksum. With this, you ensure that reliability is there of the data which you are receiving. So in case some data is lost, this can be asked again. So it can be resent again. So this is one more way of ensuring that you have very high quality video available. But yes, do a chunk of 10 seconds. Also, you can reduce this 1 second by compressing this. So you perform also various algorithms to compress the content. Right? Basically, you use here codec and so there is coder decoder. Your player, the app, will have the decoder or decompressor. You do here compressing or encoding here. So you do video compression here. So even if the 10-second video is 1 MB, let's say, with compression, this gets reduced to 0.5 MB. Right? So then what will happen? This time will save because now the content is compressed. So assume 50% compression is there. CDN replication time will also get reduced because less data has to be replicated. Network latency is also reduced because 0.5 is now required. And you just have to wait for 10 seconds here. Chunk every 10 seconds. And in case data is lost, since chunk size is small, you can very quickly resend the chunk, right? Because if chunk size is big, you again have to send that 1 minute content again, because that even if 1 second is having a problem. Because chunk is the smallest unit which you can transmit, right? And then if you have a small chunk size, then you can even correct it also very quickly. So this is one way of ensuring that you have low latency. Right. So basically what happens is you have here another server. So you have here raw video. Basically what is you are getting in the input here. Camera and mic will always record raw video. Right. It will have a lot of data. This over this high-speed internet connection will go and get into the servers. This is your server. There will be many servers because you will maintain multiple servers so that they do not crash and you have high availability. You have to ensure this is high availability because otherwise if some important match is going, you cannot ensure here that yes, for few seconds also or few minutes also, the server is down because this match will have millions of dollars of contract of advertising, right? So you need a high, definitely you have to ensure high availability. You have to do chunking. Chunking is also known as segmentation, right? Correct. And then finally you have copying to CDN, right? But yes, see what you will copy in CDN, the raw video or chunked content. Sorry, you will copy all these different kinds of video formats, right? Each of these formats, 4K, HD, 480p, you have to copy it. So these chunk servers, basically this is the segmentation server or encoder server or whatever you can call it. It will put the content into another server, which could be the streaming server. which has the streams, ready videos to stream to the CDN. Sometimes you also store one more layer here, which is called recording server. Right, so this is the recording server, because sometimes after the live streaming, the match is also available to view the recording. So this is another way of recording server. So this will also be stored in CDN. This way you will be able to do the relay of the live match in real time and in very good quality, right? Reliability is taken care here, because with the help of checksum, right? Compression ensures high-speed transfer. Compression is taking care of performance, right? Scalability, availability, performance is also taken care by CDN, right? Availability is also taken care by these servers, right? And performance is also taken care by everything here, actually, right? These servers, they split and they encode and decode. It helps in improving the performance, improves the latency also. So this is how you deliver a very good quality content. So to end users, in spite of this being in some old devices or in bad network, we'll get a very good experience, right? So he will get a very good user experience. Basically, he will be happy user, right? So this will ensure that this guy is a happy guy, right? Not bad happens. This guy is, yeah, happy guy, right? So good user experience, right?
Previously, the latency was 1 minute. And with the help of checksum and encoder and decoder, we reduced to 30 seconds.
No. Chunking was 1 minute. We reduced the chunking also to 10 seconds.
With
Right?
the help of streaming server.
Yes, yes. See,
Okay.
1 minute content, for 1 minute of chunk, you have to wait 1 minute, right?
Yes.
So definitely that will never meet your requirement. So 1 minute was a wrong choice. It should be 10 seconds or maybe 15 seconds, not more than that. You should have some room for other activities also, which is like compression and transmission over the network, replication on the CDN network. So this is how your live video content is streamed.
Okay.
Right, same diagram, I have done it in a better way. Let me paste that.
And the purpose of checksum is to only detect if there is any kind of problem in video or not.
Yes, checksum is basically checking whether there is some corruption, data corruption or not. Right?
Okay.
This one. Yes. All right, so same diagram, I will improve it and share. Is this is the same diagram, video and microphone, raw video over the internet, high-speed internet goes via load balancers to the servers where encoding and compression happens. Exact encoding number I have given, H.264 encoding is being used here, which is important for transmitting the videos. And then there will be segmentation, chunking, which will happen, right? So basically these two things happens. Then all the compressed and segmented data will be stored in streaming server. There will always be pool of streaming servers. It will also be copied to storage server so that this is for replay and download later. The information is available, right? And these streaming server content is given to edge servers, and edge servers will give the information to the clients. Clients are the mobile or TV or browser of end users. And adaptive bitrate streaming is the process which involves device detection, whether user is using 4K or iPhone or what kind of device user is using, and what is the network speed of the user. And accordingly, the appropriate resolution will be shared to the user, right? So there will be information. There will be an algorithm which will be applied in the mobile client, which will ensure that appropriate files are requested from the edge servers to be served to the users. Right. So this is about the live streaming. How do you design any live streaming server? See, in case of recorded content, you don't have this camera and mic. You have the content available. You can do the chunking and encoding as a pre-processing. You don't have to do it in real time. You may use a bigger chunk size also, because you have all the content available and you have all the time also available to do the pre-processing, and just you have to ensure that at the time of release, you have everything ready, right? And then user can view it anytime there. There is no problem with that. So if you simplify this architecture, it becomes architecture of any other channel like which provides recorded content, right? So is this clear? Right, we satisfied all the requirements, functional as well as non-functional requirements. So if you can convince to the interviewer that this way I'll be able to take care of all the functional and non-functional requirement, you will definitely do well in the interview. He will give you good feedback, good rating. And important thing is, you have to share the approach. I've told you for each and every decision which I'm taking, what was the reason behind taking that decision. So when I said that, okay, I will be using Elasticsearch, I gave you the reason why I will be using Elasticsearch. When I told that I'll be using chunking, I gave you the reason why I use this chunking. Also, I gave you the reason why I'm using 10 seconds as the chunk size, not 1 minute, right? Same approach you have to describe and share with the interviewer. Then he will definitely get convinced and he will give you good input, because this is how an architect will design a system, right? For any system, you will take similar approach and come up with the architecture. And your architecture should be end-to-end. detailed enough and nothing should be missing. As in this case, I gave you architecture from how in the stadium video will be recorded to how end user will be watching it. Right. So yes, this is entire architecture depicted here in a better manner, more visually appealing manner. Let me place this. Yeah. Good. Wow. Happy user. Right. So because he watched the match with less latency. If the latency is more than 1 minute, then definitely it's bad, but otherwise it is good. Right.
And you would be pasting that the correct one, not the correct one, but the good picture diagram for this. In this.
Pardon, here, this one?
That also will get in that document.
Yes, yes. I'll share this.
And Mr. Thoran, actually, I attended only like 3, 4, 5 classes, hardly. For the next batch, they would be starting in August, and so you would be the trainer for that, or someone else would be the trainer for that?
Yeah, that will be decided. So that we decided just before the batch and all. So yes, that's still not decided. So yeah. But yes, you can view the recordings of the previous sessions.
Yeah, definitely.
Right. Good. So yeah, so this total, no, I have given here 26 classes covering various topics in low-level design to high-level design. I'll be sharing the notes. And yes, maybe I'll check if there is possibility I can have a doubt clearing class where maybe one more class where I can do a recap and it could be for Q&A session, could be there. I'll see if that is possible based on the schedule, then that could be done.
Yesterday, you also sharing like some answer template or some solution template.
Solution template. Yes, yes.
Yes. So that also you'd be sharing?
Yes, this is there already in the Google Drive. All my notes I share. So here you have this solution template for solving HLD questions. And this is very important thing. You can use this. Always in mind how to follow it. Not everything will be applicable for all the questions, but this is a comprehensive list to ensure that when you are practicing answering system design questions, if you follow this, then you will be covering most of the aspects. You will get definitely good rating.
Okay.
Right. And then all the drawings and all which we will be doing, all the writing and the diagramming stuff, I have shared in notes, and I will be sharing for today and for recent classes also all this content, which is available as image files for you to view for all the sessions. Right. And definitely recording is there. So that would be the most appropriate reference for you to look into all this. But yes, from this, we had the session. First session was introduction session. We then did tiny URL design, low level and high level. Then I talked about various components, which was about load balancing, about web server, web application server, message queues, caching, etc. Proxy, forward proxy, reverse proxy. This all was covered. Then how to scale a website from 0 to 1 million users. What are the challenges? This was a class, next class. Then we looked into database concepts. What are relational databases? What is table, primary keys, foreign keys? What are indexes? What are transactions, atomicity, acid property, etc. We discussed. We discussed SQL, and we discussed how to design databases and how to take care of various other isolation level best practices about database design, joins, query optimization, transactions, locks, etc. We discussed about object-oriented concepts and overriding, overloading, coupling, cohesion, a lot of object-oriented concepts. So session 10, I have split in 3 parts. Then we discussed beyond object-oriented concepts, solid principles, and then design patterns. There were a few classes on design patterns. So this was all about database design and low-level design, object-oriented concepts, etc. was low-level design. Then we looked into low-level design of Book My Show and also high-level design of Book My Show, and also looked into database normalization. Then we looked into payment gateways and also caching and message queues. I also covered some of the topics which were left, which were around dry principle, Yagni, DevOps related stuff, cloud related stuff. And then had a class on microservices, API gateways, and then a few more classes I had, which was, I am yet to upload the content. Okay, let me see if I have it ready. I can do it on the fly now. So yes, last class we had on Kafka and VMs and containerization. I just uploaded this content here. Now it got here. Yes, and then prior to that, yeah, we had microservices API gateway that I have done already. And then in the previous, we had this content. This is about this API gateway. This we covered Kafka and design of e-commerce system, right? So this is covered here. So this also I'll share session 23. This is again on Kafka and various concepts, microservices design patterns. So yeah, this we covered about microservices design pattern. One pattern was microservices, then event-driven architecture. So yes, let me also upload that. And today's content also I'll share. And then some additional content I will also share so that you can view this. And definitely recording is there, which is uploaded from Zoom.
Yes.
Yes, so this will complete all the content and also material, and then let me see if I can get some classes. One classes
Okay.
for any queries, or yeah, if you guys have encountered any system design interviews or you have anything to share, we can also discuss that in some class.
Mhm. In one interview, someone asked me, did you solve any design issues? I did not get the point, that thing.
Yeah, design issues, as I was discussing, initially we created 1 minute chunk, right? So there was latency issue. So these are the things which could be discussed, that if in a system design, just discussing what are their design issues. In this, we had some design issues. Say, for example, if you don't take care of checksum, then it may happen that user is getting some file, but it is having some packets missing. So his performance or the quality of the video is not good, right? So such issues you should be able to identify in any design and should be able to take or recommend steps how to rectify it. So this is about design issues.
But let's suppose like I worked on only service-based company. I did not encounter any such issues. And in that case, I was like, should I create some content and reply?
Okay. Yeah. So see, this learning happens through practical experience, right? Basically, all these learnings, you can become architecture. Yeah, attending session is one way to learn about it. Other way is as you deep dive into some application in real projects, you will build this understanding. So I will appreciate if you guys also start applying all these concepts which I'm teaching into your real projects and start discussing among yourself. This way you will be learning things better and in fast way and more thoroughly. Because yes, definitely. I said in the first class, the sessions will give you topics what you should learn. But yes, definitely learning will also involve your research and your application of these concepts into your projects. Right? Maybe I can tell you this. For example, if I'm a language teacher, I may give you for loop is this, or but then it's solving real problem, you have to practice by applying the loops or functions or object-oriented concepts by yourself. And when you apply this, you may get more doubts, right? So you can think of, you can try doing some practice on designing some systems by your own, and then see if you have any doubts that we can discuss. You can stay connected with me. Right?
Okay.
So,
sure.
Yeah, this would be great. So you guys can be in touch with me over LinkedIn, because I can share my LinkedIn details as well. So that anytime if you have any challenges, you can always reach out to me.
Thank you. Thank you for sharing.
Sure. Perfect.
Should we disconnect it now?
Great. If no further questions, then we can close this.
Okay.
Shiv, wish you all the best.